To help us solve the inequality, absolute value of x is greater than 3, let's think of a number line. We'll put 0 in the middle, and then 1, 2, 3, 4, 5 on the right side, -1, -2, -3, -4, -5 on the left side. Our solutions to this inequality would be values that are greater than 3. And there's two parts of this number line where the values would be greater than 3. Some numbers that are greater than 3 are over here on the right side, like 5, 4, and so on, all the way up to, but not including that 3. There's also numbers over on the other side. The absolute value of -5 is 5, which is greater than 3. The absolute value of -4 is 4, which is greater than 3. So all of these numbers over on this side are also having absolute values greater than 3. Both of these sections would be solutions to that inequality. The first section represents values that are less than -3. The second section represents values that are greater than 3. So when you have the absolute value of an expression greater than a positive number, we're going to assume here that this number for right now is positive. Then we would write two inequalities. We would set that expression greater than the number. So you first write it just without the absolute value bars. And then you would write that expression is less than the opposite of that number. And you would solve both of those inequalities as needed. For example, if we have the absolute value of x minus 7 is greater than or equal to 11. First, we can pretend the absolute value bars aren't even there and write x minus 7 is greater than or equal to 11. Then you write another expression, but you switch the inequality sign and take the opposite of the number. So greater than the positive number, less than the negative number. And here we do have that equal to bar that's going to be under the greater than and less than signs as well. So on this first one, to get x by itself, we would add 7 to both sides, leaving us with x is greater than or equal to 18. The next one, we add 7 to both sides, and we have x is less than or equal to -4. Now, if we want to write this in interval notation, using the smaller section first, it would be -∞ to -4 with a bracket, union, and then we have our larger section second, 18 to infinity. Like so. Remember, infinity and -∞ would always have parentheses. Here we have brackets next to the numbers because of that equal to bar there. Let's think about our next one. Here we have the absolute value of 3x minus 5 is greater than or equal to -2. Just as with equations, when you have an inequality with an absolute value on one side and a negative number on the other side, you can stop there. Absolute value is always going to be either 0 or positive. So absolute value will always be greater than a negative number. So here, no matter what you put in for x, this inequality will always be true. Absolute value is always greater than -2. So here, when you have an absolute value is greater than a negative number, you can stop there and say your solution would be all real numbers. Or if you want to write that in interval notation, it would be negative infinity to infinity. If you'd like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. For absolute value of 2x plus 4 is greater than 12, we're going to write two inequalities. One is just 2x plus 4 is greater than 12. The second one, we still have 2x plus 4. This time we switched the direction of the inequality sign and we changed the number from positive to negative. So we would make it less than negative 12. The first one, we add 4 to both sides, leaving us with 2x is greater than 16, and divide both sides by 2, we would have x is greater than 8. The next one, we subtract 4 from both sides, giving us 2x is less than negative 16. Divide both sides by 2, we would have x is less than negative 8. I noticed a mistake I made on the first one there. When we have 2x plus 4 is greater than 12, we don't add 4 to both sides. To get the x by itself, we subtract 4 from both sides. So we would have 2x is greater than 8, and when we divide both sides by 2, we have x is greater than 4. So if we wanted to write this in interval notation, writing our smaller portion first, we would have negative infinity to negative 8 with a parentheses because we don't have the equal to bar on this problem, and then put u for union. For our bigger part here, we would have 4 to infinity.